Welcome back. Now we can go to chapter 3, FET amplifiers. Okay. When I say FET, it can be JFET, it can be MOSFET. Fortunately, both devices are having same equivalent circuit. Therefore, whatever AC analysis we do, right, for FET amplifiers, I can say applicable to both JFET as well as MOSFET. But specific to MOSFET, like the trans conductance and all, we are going to derive, and not for JFET, because JFET is not there in the syllabus. But whatever AC analysis we are doing for FET amplifiers, remember, valid for JFET also. But coming to DC analysis, we are not going to do for JFET. We are going to give only for, I'm going to give only for MOSFET. Okay. Okay, if you take MOSFET or JFET, both, right? But I'm specifying here MOSFET equivalent circuit. Heading is MOSFET or FET. Okay, that's fine. MOSFET, small signal AC analysis. Okay, if you take equivalent circuit, small signal AC equivalent circuit, right? Then if you take the MOSFET, body is not represented or bulk is not represented. Remember, the body is always connected to ground for N channel MOSFET. This is drain, source, gate, and I already explained little bit about the MOSFET structure, the three-dimensional view of your MOSFET, right? Then there is no gate current, because the space whatever we are representing here in the symbol, that is nothing but SiO2, where the current will not enter into the gate. Okay, that if you say the equivalent circuit, now this is what is small VGS, and the gate current IC is equal to 0. When I say gate current IC is equal to 0, I can say this is open circuit. When I say open circuit, the current entering into the gate is equal to 0. That is the meaning of it. And this is what the current, right? This is nothing but GM into VGS. What is GM? We will see. In the case of BJT, we had seen what is GM, and based on the definition, we derived GM is equal IC by VT. Similarly, what is GM in the case of MOSFET? That we will see after completing AC analysis. Okay, that is fine. And this is what is output impedance RD. So this is drain, this is what is source, and this is VDF. Actually, in the case of BJT, how we got equivalent circuit of BJT? We got it from two-port network analysis, and we got H parameter model. Later on, we got another model, that is hybrid pi model. This is kind of what? Hybrid pi model. In the case of MOSFET, based on the understanding, based on the concept, or based on the operation, not using any two-port network analysis. Okay. Now, this is what your ID. Okay. This is what your ID. Now, if you want to compare with BJT, right? I can compare with BJT also. In the case of BJT, right? In the case of BJT, this is collector, emitter, base. Let me give you hybrid pi model, or anything is fine. You can take H parameter model also, because that is what we used to calculate all AC parameters. That is fine. Then if you take H parameter model, then we got just listen, don't write anything. I'll give you time to write down. This is collector, emitter, and this is 1 by HOE, and this is HFE into IB. This is HRE into VCE. This is HIE. This is base, emitter. This is VBE, and this is the base current IB, and this is the collector current IC, and you are going to have VCE. Okay, this is what is our equivalent circuit of BJT. See, in the case of BJT, there is a base current, but in the case of MOSFET, there is no gate current, because it is having SiO2 where current cannot enter into gate. Now, what is the reason to have? See, this is nothing but HFE into IB. This is nothing but your current controlled current source. This is GM into VGS. This is nothing but voltage controlled voltage source. Now, this is what is the exact model or level 2, including base width modulation, right? Therefore, these two, whatever we have, 1 by HOE, and then whatever we have, HRE into VCE, these two are for what? This is what is explaining about base width modulation, and this is what is current control current source. Therefore, this is current control current source. Similarly, this is what is explaining there is no reverse transportation, means your output voltage is not impacting your input current. First of all, input current is 0, therefore your input current is not impacted by VDS, but here your input current is impacted by your VCE due to base width modulation. Therefore, HRE component has come at the input, right? But only here the RD, this is what is explaining, about channel length modulation, okay. Explaining about channel length modulation. What is channel length modulation? You will get it from device operation. When VDS increases, your ID also increase because of VDS. But I am expecting ID to be controlled by only VGS. But your ID is also a function of VDS. That's why the small RD is also represented. Therefore, explaining about channel length modulation. How we have base width modulation, similarly channel length modulation. Okay, and the GM into VGS, that is nothing but voltage controlled current source, right? This is what your H parameter model, right? Then we got another model, hybrid pi model. There also we have GM into VBE, etc., right? But I am taking only H parameter model, and this is what is including base width modulation or channel length modulation. Now I can give you another model without channel length modulation. Therefore, now the model without second order effect, second order effect or higher order effect is nothing but without channel length modulation. If there is no channel length modulation, or if you neglect channel length modulation, that is what people represent. I am going to explain that later. Therefore, this is what is your lambda, where lambda is equal to 0. There is no channel length modulation. If there is no channel length modulation, then what does it mean? The output current, whatever you have, it is only a function of VGS. It is independent of VDS. That is the meaning of not having any channel length modulation. Means your output current will not change with respect to VDS. Okay, fine. Then if you consider that, then the equivalent circuit will be, this is what is your VGS, gate, source, the gate current is equal to 0. Okay, and this is what is GM into VGS. Now RD is not there, right? Therefore, it is simply drain and source. This is your VDS. The current is ID, right? Therefore, this is also voltage controlled voltage source. But if you include overall, this is not a practical voltage control current source. But here it is ideal voltage control current source. Therefore, you can say this is what is ideal. That's what people call this as ideal model of your MOSFET level 1, right? There is no channel length modulation effect. Ideal voltage controlled current source. Your ID is simply GM into VGS. Okay, your ID is independent of VDS. Okay, but here your ID is depending on VDS. That's why another branch which is RD, where ID is equal to GM into VGS plus I am writing KCL. Therefore, this current is equal to this current plus this current. ID is equal to GM into VGS plus the current which is what is flowing through RD. That current is nothing but what? VDS divided by RD. Means the current which is flowing through RD is depending on VDS. Okay, that's fine. Here the current which is what is flowing through drain to source or the channel is only depending on VGS, independent of VDS. Okay, that is fine. Now coming to your BJT, neglect base width modulation. When you neglect base width modulation, that is nothing but without base width modulation. Without base width modulation, right? That is nothing but what? HOE is equal to 0 and HRE is equal to 0. That is what is our simplified model. Simplified model is nothing but neglecting base width modulation. Then what does it mean? The circuit will become, it is simply, we had seen this, right? This is what is our HIE. This is base, emitter, collector, emitter. This is VBE and this is your base current IB. This is HIE. This is HFE into IB, and now this is VCE and this is IC. Therefore, if you observe clearly, IC is only function of IB, right? It is independent of VCE. And your IB is only function of VBE. IB is independent of VCE, right? But if you consider base width modulation, your IC not only function of IB, it is also function of VCE, because the current which is flowing through this is also depending on VCE. Therefore, IC is also function of VCE. Now, and at the same time, IB is also function of VCE. Therefore, your IB is also affected because of VCE. This is what is called reverse transportation. That's why people call this as reverse voltage gain. Okay. Now, this is what is your simplified model, or people call it as ideal model, but it is the current which is what is flowing through collector to emitter is only function of IB. Therefore, this is ideal current control current source. But the same thing is modeled, or we also model with hybrid pi model. Then it is nothing but something like, if you want to compare like this, like if you want to represent voltage control current source, then GM into VGS, here GM into VBE. Whatever input voltage you have, that is what GM into that input voltage will be your output current. In that way also we can get it but that is ideal model if you neglect output resistance, etc. That is what is base width modulation. Okay, take it. But maybe you can go ahead with this. If there is no channel length modulation, right, then what is RD? RD will be infinity, right? Maybe you can say lambda is equal to 0, but this is what is implying small rd. Actually there is a formula 1 by lambda into id, which is infinity. There is a small rd is nothing but 1 by lambda id, we can take it as infinity. Because lambda is equal to 0. When lambda is 0, 1 by 0 infinity. Quantitatively 1 by lambda id, but qualitatively if there is no change in id because of VDS, whatever branch that is open, therefore RD is infinity. Done. You take it. I'm just trying to correlate between BJT to MOSFET. Then let's use this to calculate all your AC parameters. Right? That is fine. And one more point I want to tell. Whatever observations we studied or we got related to BJT, let us say common emitter amplifier is giving very good voltage gain but no impedance matching. Common source amplifier, because when I say emitter, emitting the carriers, source, sourcing the carriers, collector, collecting the carriers, drain, drainage of carriers, base, that is what is the control, which is what is controlling the current between collector to emitter, gate, controlling the current between drain and source through the channel, right? That's why common emitter, common source, common collector, common drain, common base, common gate, CE with RE, CS with RS. Whatever we had studied in the case of BJT, similar configurations we are going to study in the case of MOSFET. What are all observations we got related to BJT, similar observations we are going to get from MOSFET. Okay, take it. Let me have some water. In the meantime, you try to write. Okay. It's not BMW, it is BWM, base width modulation. Okay. I'll give you 2 more minutes. Then after that, let's see the configurations from MOSFET. This is H parameter model. Actually, we have another model, right? Hybrid pi model. over Therefore, let us use this equivalent circuit, right? Then let's solve all AC parameters for a given configuration from MOSFET. Now, don't write, listen. Let me take a generic circuit which covers the configurations what we had seen in the case of BJT instead of doing individually. Then if you do individually, that is redundant. Okay, means the same thing again we need to solve. Therefore, instead of that, you just see this is what is the circuit where this is your input voltage, let us say, and this is VDD, RD, RS. Let me call this as V01 and let me call this as V02. It's not that we have two output voltages. I'm just taking either I can take this is what is my output or this is what is my output. Okay, anything we can define, but what it may be, first of all, in a generic way, before going to the configuration and then observations, let us calculate what is V01 with respect to Vi and what is V02 with respect to Vi. This is a drain, source, gate. Okay, now if you ask me how many parameters we used to calculate from BJT, we used to calculate voltage gain, current gain, input impedance and output impedance. Here we need not calculate all four AC parameters. For a reason, if you take, we are applying input voltage in these configurations, applying input voltage at a gate. When you apply input voltage at gate, tell me the current which is entering into gate. We know that the current entering into gate is equal to 0. Then tell me what is input impedance. What is input impedance? Input impedance is infinity. No need to calculate. Because input impedance is infinity. Wherever you are applying input at gate, remember, because the current entering into gate is equal to 0. Unlike BJT, the current entering into base is not 0. There is a current which is entering into base. That's why it is defined with some input impedance, input resistance. Okay. Here, when you apply the voltage Vi, there is no current entering into gate. The gate current is equal to 0. When I say gate current is equal to 0, input impedance is infinity, right? Therefore, out of 4 AC parameters, input impedance infinity, no need to calculate. Now, current gain. What is current gain? Tell me the definition of current gain. Output current or the current which is entering into load divided by the input current, the current which is entering into your amplifier. Tell me the current which is entering into your amplifier. 0. Output current, yes, there is output current divided by input current, 0. Then output current by 0, infinity. Is current gain infinity? Is current gain infinity? Yes, according to the definition, AI is equal to IL by I1. I1 is 0 because input current is 0, then current gain is infinity, right? Typically, let us say I am taking a black box, I am saying current gain infinity. When I say current gain is infinity, what does it mean? Whatever current you are pumping, infinite amount of current you get at the output. Is that what true? No. Infinite amount of current we are not seeing at the output, right? Here, current gain is not defined. We should not define current gain because it is not doing current amplification. Because input current is 0. It is not even taking any current. Then how can you say there is a current gain? No, we cannot say that. Therefore, remember, out of 4 AC parameters, input impedance is infinity wherever you are applying input voltage at gate, and current gain is undefined, no need to define. because input current is equal to 0. Then left with only two AC parameters. Number 1, voltage gain. Number 2, output impedance. Right? First of all, let's calculate voltage gain. Then let's see output impedance part from each configuration separately. Now this is generic circuit where it covers 4 configurations. Number 1, V01 divided by Vi, CS with RS amplifier. V01 divided by Vi when RS is 0, common source amplifier. V02 divided by Vi, CD with RD amplifier. V02 divided by Vi when RD is equal to 0, CD amplifier. Therefore, we are getting 4 configurations. Therefore, we will see what is each and everything one by one. But let us get generic the relation V01 to Vi and the generic relation V02 to Vi. Right? Let's calculate. Now, it is like AC analysis. When I say AC analysis, we have to consider AC circuit. Everything we need to replace with its internal circuit or dynamic resistance or dynamic equivalent representation. Then we need to calculate V01 by Vi, V02 divided by Vi. Everyone understood? Draw the circuit and then wait for some time. Then let's have the derivation. Then we will see V01, V02 with respect to Vi. Okay? Take the circuit. Then I will give you AC circuit. Then we will derive. Because there is no input impedance and there is no current gain, it is faster. If you compare with BJT, it is faster. And the concepts what we studied in the case of BJT can be applied to MOSFET also. Okay? That's why I don't need more time for the MOSFET analysis. Okay? Just 10 seconds. Over? Okay. Now, listen, don't write. I want to write AC circuit. What is AC circuit? We need to replace everything with its internal resistance. Let us replace first of all your MOSFET with the circuit what we had seen before, right? That is nothing but this is gate, source, this is VGS, right? And this is nothing but your voltage control current source, GM into VGS, and small RD. This is a drain and source, right? This is what your MOSFET AC equivalent resistance or dynamic representation. Now tell me, between the source and ground what is defined? RS is defined, right? Therefore, between source and ground, RS is defined. This is your RS and this is what is your V02, let us say. This is your RS, okay? Now, between gate and ground, what is defined? The input voltage. Between gate, remember your VI is not VGS because we have RS, okay? This is your input voltage, VI. Between gate and ground, that is what your VI. Between drain and what is this VDD for AC analysis? VDD is connected to ground, AC ground. Therefore, this RD, because there is no change in VDD, this RD is connected to between drain and AC ground, or drain and ground. Drain and ground. This is your RD and this is your V01. This is the definition. And let's represent the currents. And one more thing, in the case of BJT, if you treat this as BJT, base current, collector current, that is emitter current. Therefore, collector current plus base current is nothing but emitter current. But in the case of MOSFET, the drain current is nothing but source current. Whatever current which is what is entering into drain, the same current is coming through the channel and then coming out of source. That is what is your channel current from MOSFET operation. Now, and there is no gate current. Therefore, whatever current which is entering into drain, KCL, same current should come out of the source. Okay, if you think from KCL perspective also, right? Therefore, if you ask me, this is nothing but your drain current ID, and the same current is coming out of source, that is what is IS. Therefore, what is IS? IS is nothing but ID. Therefore, IS is nothing but ID. Now, if I represent that, tell me the current which is entering into drain. The current which is entering into drain is nothing but ID, and the current which is coming out of source is also ID. Okay. Now, according to the load, let us say the current which is entering into RD, let us say this is what is the current. What is this current? This is minus ID, or I can say, that's fine. If you say this is what your load current, you treat this as a load, IL is equal to minus ID. Therefore, this is what? The black one is nothing but your MOSFET, and the remaining things are external components to MOSFET, and this is AC circuit. Okay? Just listen. Now, what is our aim? Our aim is to get, what is V01? V01 is equal to, what is V01? From this, the load current into RD, which is nothing but what? Minus ID into RD. What is V02? V02 is nothing but the drop across RS. That is nothing but ID into RS. Small ID into RS. Okay. Take this as equation 1 and equation 2. Now, if you are trying to find ID in terms of VI, if you are able to find ID in terms of VI, then we will get V01 with respect to VI. That is what is our ultimate aim. Okay. Now, let's find ID. Therefore, to find ID, to find small ID. Now, KVL. If you write KVL, it will help you. Therefore, what is KVL? This voltage is equal to this voltage plus this voltage. Or if you write loop KVL, that is also fine. Because individual people will have their own way to write the KVL equations. But normally I prefer a voltage will be dropped across any branches what you have in the loop. Therefore, this voltage is equal to this voltage plus this voltage. Therefore, what is the drop across RD? The drop across RD is equal to minus ID into RD. That is nothing but drop. Okay. Is equal to, the drop is equal to, what is the drop across your RD? Which is basically VDS. But don't write in terms of VDS. Try to write everything in terms of ID only. Okay. Therefore, now tell me what is the drop across RD? Can I say ID into RD? No. Because this current is not flowing through RD. This is nothing but this plus this. Now if you know the current which is what is flowing through RD, then I can find the voltage drop across RD. Now can I say the current which is what is flowing through RD is nothing but out of ID, GM VGS is going in this branch. Therefore, this is nothing but ID minus GM into VGS. This is the current which is flowing through RD. Now KCL is satisfied, right? Out of this ID, GM VGS is gone, remaining current is flowing through small RD, right? Then, therefore, what is the drop across small RD? ID minus GM into VGS into small RD plus the drop across RS, which is nothing but ID into RS. Okay. Now we can take this ID in capital RD to right hand side and take ID common. You'll get simple form. Okay. Now, if you take it and then take ID common, you'll get capital RD plus small RD plus Yeah, we can continue. Now, yeah, if you take ID common, capital RD plus small rd plus RS, and we have something that you can take to right hand side or left hand side, which is what is becoming plus, is equal to GM into small rd into VGS. Okay. Now, let mu is nothing but amplification factor. I'll explain the significance of mu. Therefore, let mu is equal to GM into small rd. Okay, this is what is called amplification factor. Amplification factor. Why it is called amplification factor, you will understand once we see one by one configuration. Okay, that's fine. Therefore, what is our ID now? Your ID is nothing but capital RD plus small rd plus RS is equal to mu into VGS. Therefore, now we got ID in terms of what? We got ID in terms of VGS, right? But what do you need to get V01 with respect to VI? I want ID in terms of VI, but we got ID in terms of VGS. Now try to get the relation between VGS to VI, then you substitute, you'll get ID in terms of VI, problem is over. Okay, maybe you can call this as equation 3. Actually, this is what is our output KVL. We are using output KVL. Output KVL. Okay. Now input KVL. Input KVL. What is input KVL? This voltage VI is equal to the drop across this plus the drop across this. This is equal to this plus this. Therefore, VI is equal to VGS plus the drop across RS, which is ID into RS, right? Therefore, this voltage is equal to this voltage plus this voltage. Therefore, now what is VGS? Therefore, VGS is equal to VI minus ID into RS. You substitute that in equation 3. Therefore, 3 implies, what is your ID? If I take ID common, you will get capital RD plus small rd plus RS is equal to mu into, what is VGS? VI minus ID into RS, right? Therefore, again ID has come. That ID you take to left hand side. Then, if you take ID common, you will get capital RD plus small rd plus RS plus mu into RS plus mu into RS is equal to mu into VI. Therefore, what is your ID? Therefore, ID is equal to mu into VI divided by capital RD plus small rd. I'm just taking to right hand side. Therefore, capital RD plus small rd plus, if you take RS common, 1 plus mu. Therefore, plus 1 plus mu into RS. This is what is your ID. You can call this as equation 4. Now we got ID in terms of what? VI. Now you substitute that ID in both 1 and 2, then you will get V01 with respect to VI, V02 with respect to VI. Then problem is over. Therefore, what is 1? 1 implies, what is V01? V01 is equal to minus ID into RS, minus mu into VI into RS divided by, RD divided by capital RD plus small rd plus 1 plus mu into RS. Therefore, V01 divided by VI, if I take this to left hand side, minus mu into RD divided by capital RD plus small rd plus 1 plus mu into RS. This is what is your V01 divided by VI, just generic formula. Similarly, 2 implies, what is 2? ID into RS. Therefore, V02 is equal to ID into RS. mu into Vi into Rs divided by capital Rd plus small rd plus 1 plus mu into Rs. Then if you take V02 divided by Vi is equal to mu into Rs divided by capital Rd plus small rd plus 1 plus mu into Rs. This is the second formula which you need to remember. I am keeping in the boxes. Those things you can remember as formulae. Okay? Take it. I think now you understood the procedure. Just replace MOSFET with small signal AC equivalent circuit. Then everything replaced with AC dynamic resistance. Then calculated V01 with respect to Vi, V02 with respect to Vi. Once you know these two formulae, then let's see one by one. Right? All configurations related to the circuit. Okay? Take it. You have 3 more minutes for this session. Then try to cover in 3 minutes. Else you can pause the video and you can write down. Okay?